Good day everybody, we got an interesting question. We are expected to integrate integral 0 to pi square root of 1 negative cos x divided by cos a negative cos x times dx. Now this problem is very unique. Now why is it very unique? Because it gives us that particular information which is very imperative for us to make the distinction between so-called software and human intelligence. Now, why do I make this statement is that this question is practically unsolvable by Wolfram Alpha. If you were to put in this particular question into Wolfram Alpha, it will just say the time required just exceeds. In other words, it says it is not able to calculate this particular question. Simple as that. So having mentioned that, let us build our intelligence by handling this question. So foremost, what I wish to do is I would like to draw your attention to this all important formula, which is 1 positive cos 2x divided by 2 is equal to cos squared x, and also to this formula 1 negative cos 2x divided by 2 is equal to sin squared x. Now I will be utilizing this formula to represent the numerator. So from here what I can do is I can rewrite 1 negative cos 2x to be equal to 2 times sin squared x. Then I can push this to the right side, bring this to the left side. That would give me 1 negative 2 times sin squared x is equal to cos 2x. Now I would like to have cos x. So let us imagine a situation where 2x is equal to t. Therefore x is equal to t over 2. So rewriting this is going to be 1 negative 2 times sin squared t over 2 is equal to cos t. Now since this variable is in t and there aren't any exponents to the variable t, I can safely rewrite this to be the original variable x. So this is equal to 1 negative, in fact I can rewrite it in any variable, that doesn't matter. Since we got x, I'm just going to be rewriting it in terms of x. So this is equal to 1 negative 2 times sin squared x over 2 is equal to cos x. So wherever I see cos x in the question, I will be utilizing this formula. So let me consider the numerator. Consider the numerator. The numerator is 1 negative cos x. So in place of cos x, as I mentioned to you, I will be replacing 1 negative 2 times sin squared x over 2. Rewriting this can give us 1 negative 1 negative positive 2 times sin squared x over 2. Negative 1 positive 1 goes off, giving me 2 times sin squared x over 2. Now what is this numerator? This is 1 negative cos x. So if 1 negative cos x is this, therefore square root of 1 negative cos x is going to be square root of 2 times sin squared x over 2, which is going to be root of 2 times square root of sin squared x over 2 would give us sin x over 2. Fair enough. So this is our numerator. Now we need to consider the denominator. Consider the denominator. So what is the denominator? We have square root of cos a negative cos x. Now as I told you, we know a formula which is cos 1 plus cos 2x divided by 2 is equal to cos squared x. So this can be rewritten by taking 2 to the right hand side. So 2 times cos squared x is equal to 1 positive cos 2x. I can push this 1 to the other side. So it's going to be 2 times cos squared x negative 1 is equal to cos 2x. If I were to take 2x is equal to sum t, I get x is equal to t over 2. So this is going to be cos t is equal to 2 times cos squared t over 2 negative 1. Now this can be reverted back to our x variable. So we got cos x is equal to 2 times cos squared x over 2 negative 1. So wherever I have cos in the denominator, I will be utilizing this formula. Also cos a can be rewritten as 2 times cos squared a over 2 negative 1. So let me substitute these values in the denominator. So first let me consider, instead of saying root of cos a negative cos x, let us evaluate cos a negative cos x first, which is equal to, in place of cos a I will be substituting 2 times cos squared a over 2 negative 1. Negative, in place of cos x I will be substituting 2 times cos squared x over 2 negative 1. This can be rewritten as 2 times cos squared a over 2, negative 1, negative 2 times cos squared x over 2, positive 1. Positive 1, negative 1 goes off, giving me 2 times cos squared a over 2, negative 2 times cos squared x over 2. I can take 2 out, so this is going to be cos squared a over 2, negative cos squared x over 2. Now this is nothing but cos a negative cos x. So therefore, if I were to take the square root, this is going to give me root of 2 times square root of cos squared a over 2 negative cos squared x over 2. This is what we've got for the denominator. So therefore, the question integral 0 to pi root of 1 negative cos x divided by cos a negative cos x times dx is rewritten as 0 to pi root of 1 negative cos x divided by root of cos a negative cos x times dx square root of 1 negative cos x. What is that? We have already evaluated that. That is nothing but root of 2 times sine x over 2 divided by, what is this? This is nothing but root of 2 times square root of cos squared a over 2 negative cos squared x over 2. So you got the dx there. So root of 2 gets cancelled, giving me integral 0 to pi sine x over 2 divided by, now from the denominator let me take cos squared a over 2 out, so I will get 1 negative cos squared x over 2 divided by cos squared a over 2 times the dx. Now let me move to the next page. So from here, this is equal to integral 0 to pi sine x over 2. I can apply the square root, so that would give me root of cos squared a over 2 times the root of 1 negative cos x over 2 divided by cos a over 2 the whole square times dx. So this is equal to integral 0 to pi sine x over 2. Now root of cos squared a over 2, you apply the square root, you get cos a over 2. So you can write it like this, divided by root of 1 negative cos x over 2 divided by cos a over 2 raised to the power of 2 times dx. Okay, so now what I'm going to do, I'm going to make a substitution. Let cos x over 2 divided by cos a over 2 be equal to some t. I differentiate, this is constant, right? So this means this is nothing but 1 over cos a over 2 times cos x over 2 is equal to t. That is the exact meaning. So if you were to differentiate this, this is going to be cos a over 2 is a constant. Differential of cos x is going to give me negative sine x over 2 times the quotient, or I should say the coefficient with x is 1 over 2. So that has to be multiplied. So differentiation of cos is sine with a negative sign, and the coefficient of x is nothing but 1 over 2. So that has to be placed times differential operator dx. This is equal to dt. Now this can be rewritten as negative sine x over 2 divided by cos a over 2. Of course there is a 1 over 2 there. I will write 1 over 2 like this times the dx is equal to dt, right? Now we don't have 1 over 2 in the quantity here. So what I wish to do is I will just rewrite this as, therefore, sine x over 2 divided by cos a over 2 times dx. I'll push the 2 to that side with the negative sign, so it's going to be negative dt with the 2 there. So in place of this you substitute this. So therefore what happens, integral 0 to, I'm not going to place in the limits as yet, I need to check the limit, so I'll be coming back here. So this is going to be negative 2 times dt. In place of sine x over 2 divided by cos a over 2 times dx, I'll be substituting negative 2 times dt, and then divided by square root of 1 negative. In place of cos x over 2 divided by cos a over 2, I'm going to be substituting t. So this is going to be t squared there. Now let me go to the limits now. So when x is equal to pi, cos pi over 2 is 0. So t is equal to 0, right? And when x is equal to 0, substituting x is equal to 0 here. So this is going to be cos of 0 divided by 2, which is cos 0. Cos 0 is 1. So therefore the value of t is going to be 1 over cos a over 2. So we need to substitute the limit. So what I will do is, I will just say alpha beta, and over here I will make the substitution. So in place of pi I got 0. In place of 0 I've got this value 1 over cos a over 2, and you got this negative 2. I'm taking it out, so dt divided by root of 1 negative t squared. Now I can flip the limits and get the negative sign annihilated. So this is going to be 2 times 0 to 1 over cos a over 2 dt divided by root of 1 negative t squared, which is going to be 2 times sine inverse of t. The limits are 0 to 1 over cos a over 2, right? So this is going to be 2 times, I substitute the upper limit, sine inverse of 1 over cos a over 2, the upper limit, minus sine inverse of 0. So sine inverse of 0 gets cancelled, so the value is going to be 2 times sine inverse of 1 over cos a over 2. This is the solution for this particular question. And please like, share and subscribe and leave your comments, and until we meet again, thank you.